Hello, everybody. I'll be making my presentation with my colleague, Jerry Mahar, testing for unit roots in autoregressive moving average models of unknown order critical comments. So this is the title of the presentation book. This is the title of the presentation. Here is going to be my presentation outline. I'll discuss introduction, why this study is important, critical review of Dickey Fuller and Augmented Dickey Fuller tests, replication results, additional results, and conclusion. My presentation is not going to take very long. So I would like to keep it short and simple. So in the introduction, why this study is important. This test has been used for a long time. Obviously, people received Nobel Prize in economics. As a teacher of economics, I wanted to learn about these methods. And once I started learning about it, and I saw a problem. And once this problem became known to me, I wanted to share with other fellow economists, with other fellow economists. We find it very curious that no econometrics textbooks contain explicit warning against the dangers of the unit root tests. That is interesting. And because well-respected applied works still make use of unit root tests. So, and we consider it is timely for a critical review of this method. We have two objectives in this paper. First, we replicate the exact results reported by Said and Dickey in Biometrica. And we've, at the outset, we confirm their research, what they were doing, that was good. But what is troublesome is what they did not report in their paper. It casts doubt on the ADF tests. And we are going to present these results. Pure random walk model, random walk model and random walk model with drift and time train, autoregressive moving average of unknown orders. These are the methods of testing for unit root. In pure random walk, those people familiar with regression analysis. So it is y equals xt plus error term. It does not have any intercept. A random walk with drift, it is y equals alpha plus beta xt plus et. It is intercept term plus intercept term is included with the random walk with drift. So in random walk with drift and time trends, these developer of this test realized that including a drift term is not enough. Maybe there is some kind of time trend also involved in the data. So they also wanted to capture time trend, and that is they devise this method is xy equals intercept alpha plus beta t, beta is the time trend, plus xt, beta 1 t and beta 2 xt, and error term. That is the regression regression method used in random walk with drift and time train. And autoregressive moving average of unknown orders, like say, what happens is in the regression analysis, the designer, they are regressing this same variable with its past observation, and how far back they would like to go. They did not know, when they were designed, they did not know. So they also developed a mechanism. In this case, all these things, pure random walk model, random walk with drift, and random walk with time train. So all these are combined, and that can be tested using the statistical analysis. So we will show, like what, like we can reproduce the results exactly what the designers or the developers of these tests were developing, but our contribution to the literature is, hey, whatever they were doing, it was they were doing just in a way, those things were an exercise, but doesn't work in the practical real world data analysis. So, and we'll say why. The source of the controversy, source of the problem in ADF tests, and the choice of the length of time lag, how many lag, 0, 1, 2, there are different tests, other statistical tests, AKIK information criteria or source information criteria. There are some other rules they used, they have used, but they do not produce. One important point to note is that they do not always yield identical results. So what it means, different people using different methods, and they can say the series is stationary or the series is non-stationary. Like, and we say, how come a series is stationary? If one analyzes and comes to a conclusion, how come a series is stationary and the same series is analyzed by another person, the series is non-stationary? We consider that is not a very valid scientific approach. So, so we revisited the source of this controversy and discovered that none of the studies in the extant literature went far enough to point out the limits of Dickey Fuller and augmented Dickey Fuller tests. And it was this gap in the literature that we sought to fill in this paper. Particularly, we provide additional statistical results not reported previously in the Dickey's Biometrica article, Dickey Fuller's Biometrica article, and why new results, that the results that were present in this paper, cast doubt on the continued usefulness of ADF tests. So this is the data. The source of the data is Box and Jenkins, 1970. There is a book by Box and Jenkins. This is well established, like very well known, well regarded. So, and we plot this data. The Box and Jenkins also report this graph in their book, but they ignore, they simply show this variable from a small band. And then we see the series is very fluctuating a lot, okay? So, but when we look at, given the context, like this graph, put it in, start from 0, and then we see, oh, it fluctuates, but it does not fluctuate a lot. So it fluctuates between 2 points, point 16 and 18. Like there is well fluctuation here. And the question actually is this series stationary or non-stationary? We see fluctuation between two values, 16 and 18. Is this fluctuation enough just to consider this series non-stationary? No? That was our original intent to analyze this data. So we look at the summary statistics. These are the summary statistics, and these summary statistics are not available in Dickey Fuller and Box and Jenkins. We provide it here. We exactly replicate the results. The results are here. Said Dickey Fuller, they report only these statistics. They report first column, and Dickey Fuller tout statistics. They report these, and we are able to reproduce these Dickey Fuller tout statistics exactly the same. And but we also report, these are the results. We get exactly the same results as Dickey Fuller did, and these are the additional results, regression results. And important, the findings are reported here. Main findings: the series is non-stationary, 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 non-stationary. So all these results indicate that the series is non-stationary. Okay, good. So having established that we are able to reproduce their results exactly, so now we will do, nothing, we do not change anything. We just run the regression. What happens to the results if we look at other um, um, other. So here, so if we look at, like if we look at if we do not include other lagged variables, then the series becomes stationary here. So if we look at only one lag, here it is without constant term. So series is stationary. If we include first lag, series is stationary. If we include second lag, series is stationary. Third lag, second lag, third lag, fourth lag, fifth lag. If we include fifth lag, series is stationary. So our main finding is stationary. Okay. So now let us look at what happens if we continue to include sixth lag. That was the main. Seventh lag. If we include seventh lag, series becomes non-stationary. Eighth lag series becomes non-stationary, and ninth lag series becomes non-stationary, and 10th lag series becomes non-stationary. So in the original data set, the results indicate that including more than 5 lag converts the series to become stationary, produces the results non-stationary, including less than 5 or less where is autoregressive lags, converts the series into become stationary. So, because they emphasized, they were confident in their analysis that, okay, they have to include more than 6 lags, so they reported only more than 6 lags. But if we look at the big picture, if we look at all lags, then more than 50% of the time the series is stationary, but they reported only the non-stationary part. Okay, that created the problem. Like nobody looked this one. We are the first ones just to look to reinvestigate this paper, and then this is our contribution. So additional results, looking at different methods. Here we look at the lags. One, so we have to look at y dimensions, the coefficient here. So these are, and if we look at this outcome main findings, it is stationary, 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 stationary. If we include the sixth lag, it becomes non-stationary. So actually, table 3 and table 4 complement table 2. So this is table 2, main results, like these tau statistics, Dickey Fuller tau statistics are reported in original biometric paper by Dickey Fuller. So, and we are able to reproduce these results. So these results are complemented. Table 3, they did not report. In table 4, they did not. Table 3 is a big table, long table. So table 3, this is table 3, part 1. Continuation here, some variables are not included here, and those variables are included here. So all 10 lags are included here. So table 3, this is table 3, and table 4, another way is to look at, and we find the series is, depending on the model chosen, the series can be proved, can be called stationary or non-stationary. So we also looked at the matrix of correlation coefficient. these variables are very, they are not very correlated. After first lag, first lag is correlated, is correlation coefficient is 0.57, that 57%. So after these numbers are very small. They are not really, we cannot consider them, they are correlated. So main findings, our data analysis reaffirms the internal validity of the research design by Said and Dickey. We found that Said and Dickey selectively reported some results that supported the findings of the Box and Jenkins 1970s paper, 70s book actually. The additional results from the data analysis not reported previously by Said and Dickey cast doubt on the continued usefulness of the ADF test. The reason is you can prove anything you want, and we do not consider that is a scientific method. So this completes our presentation. If you have any question, please contact me and I'll be happy to answer any questions. Thank you very much.